Hello, algebra students. This is Mr. Lawrence here, and we have an I Can video. This is kind of a little check along the way because this unit is very long, and we're making sure that we're mastering the topics as we go. And after this video, this should all be reviewed, by the way. You should be able to say, one, I can solve systems of linear equations by graphing, substitution, or elimination. And to add to that, you're going to be able to say, I know when to do which method. Number two, I can solve systems of linear inequalities by graphing. And three, I can identify and write equations of parallel and perpendicular lines. All right, let's get down to it. Here I have three systems of equations. Now, I'm going to warn you that on a test or a quiz, you're going to have to be able to tell um, which type of solution you should use, graphing, substitution, or elimination, which method you should use, I should say, to get your solution. Um, I'm not going to tell you, but I'm going to require you to do all three. So let's see here. Let's see if we can try to figure out when we should do which method. So I'm looking at this first set of equations, and I notice that I've got a negative 6y and a positive 3y. Pretty easily, I could double the second equation and then add them together, use the elimination method, my y's would cancel out. So I think I'm going to use elimination on this method. Now you notice that I'm not solving it right away. I just think I'm going to do elimination. I'm testing it. Okay, I'm going to go on to the other two systems and decide which method to use. And then if I find another method lends itself to elimination better, I might change my mind. But the danger is if I do it first, if I say, okay, I'm going to do this one by elimination, and I do it by elimination, and then the other problems are more difficult to graph or do by substitution, then I haven't made a very good choice. This way I'm going to look at all three systems ahead of time, and I'll decide then what I'm going to do. All right, so uh, equation number two. I'm not sure what I want to do about that yet. I was thinking graphing, but I mean the bottom one would be pretty easy to graph, get it in slope-intercept form. But the top one, I'm going to have a y-intercept of 2/3. I'm not sure I like it so much. Let me go to number three here and see. Ooh, the first one's in standard form. The second one turns into slope-intercept form pretty easily, and uh, the intercepts are whole numbers. So this one is going to be my graphing one. Now, again, I'm not solving them just yet. I'm going to look at this one and make sure it's good for substitution. Well, yeah, it'd be pretty easy to get the y alone, wouldn't it? So I think I will go substitution on this method here. Okay, now I'm not going to solve them in order. I'm going to solve the one that I think is easiest. If my favorite method is graphing, I'm going to do that one first. In fact, you know what? Graphing is pretty easy for me. I think I will do the graphing first. So let me get a new page here. And there we go. And let me get some graph paper. And I don't know why that's happening, but it is. So it's no problem. Let's see, there we go, it's gone. Let me lock him in place. All right, so I'll tell you what I'll do is I'll graph this one in red and I'll graph that one in green. Now the first one's in standard form. So I'm going to get the y-intercept right away. And I believe that's c divided by b. And that'll be 0, -8. That's my y-intercept. So I'm going to plot a point at 0, -8, 10, 9, 8 right there. There we go. And I'm going to infinitely clone him because remember, I don't like to graph right away. I like to get all my points on there and see if I can determine where they're going to cross before I draw my lines in. Okay, so the slope is going to be negative of a, so -3, over b, -1. So that'll be +3. So my slope is 3 over 1. So now I'm going to go 1, 2, 3, 1. And notice 1, 2, 3, 1. And 1, 2, 3, 1, 2, 2, 3, 1. And we'll do one more. 1, 2, 3, 1 because I don't know where they're going to cross. I will draw the line in a minute. Now, this second equation here, I'm going to do it in green, I need to get y alone. So I'm going to subtract 4 from both sides. And I'll get 3x minus 4 equals negative y. I don't want y to be negative, so I'll divide by negative 1. And remember, I have to do it in all three places. Okay, so y will equal negative 3x plus 4. Okay, the y-intercept is going to be 1, 2, 3, 4. And I'm going to infinitely clone him. And we're going to go down 1, 2, 3, 1. And go down, oops, from there. 1, 2, 3, 1. Oh, look at that, they cross. So I know right now that my solution is going to occur at 2, negative 2. Looks like I picked a good one to graph. Answer came out pretty, right? Okay. Get my two lines here. And I'm just going to smack arrowheads on by writing instead of going through all the property stuff. There we go. And then this one goes something like that. And I try to make it a little bit tighter so that it's crossing at the place I say it is. I'm trying to be precise. And there we go. And if I want, I can draw attention to it, but I don't have to. All right, so that is solving by graphing. Now, I need to do the other two. And again, do the one that you're better at. If you're better at elimination, then do it first. If you make lots of mistakes with elimination, do substitution first. And I'll be honest with you, when I was your age, I did elimination whenever I could. I thought it was better. I thought it was easier. And as I got older, I realized I was better with substitution. I made less mistakes with it. So I'm going to go ahead and do number 2 next. I'm going to solve for y in this second equation. And I'm going to get y equals 3x plus 8. So now I rewrite the first equation, 4x plus 2 equals 3 times the quantity, and I substitute in 3x plus 8, 3x plus 8, and there we go. Now I'm ready to distribute on the right-hand side. I'll have 4x plus 2, it'll equal 9x plus 24. Oh, okay. I'm going to get rid of one of the 4 x's, take one away, because I don't want x's on both sides, and I know my x is going to end up on the right-hand side, so I might as well get rid of the 24 all in one fell swoop. It should not be difficult for you at this point. It should be okay that I'm taking more than one step on the same line. Now, I am showing my work. All right, so now I have 5x equals negative 22. I'll divide by 5. And then x is going to equal negative 22 fifths. Now when I report my answer, I'm going to use negative 4 and 2 fifths. Okay, I don't know what y is yet, but when I do my calculations, I'll probably go back and forth between mixed number and improper fraction. I'm going to start with the improper fraction. Okay, to get y, I think this would be the best equation to use. So I'm going to write y equals 3 over 1 times negative 22 over 5, and then I have to add 8. So y is going to equal negative 66 over 5 plus 8. Y is going to equal, well, I know 5 times 12 is 60. There's room for another 5 in there, so it must be negative 13, and it's 1 short because that'd be 65, 1/5 plus 8, which will simplify to negative 5 and 1/5. And there we go. I'm glad I didn't pick this one to graph by, because it would be difficult to tell that it's crossing at 1/5 and 2/5 in most situations. All right, last one, number 1. I mentioned earlier that I was going to double the second equation, right? And so my two equations are the original 10x minus 6y equals 22. And then the one I doubled will turn into 4x plus 6y. That'll equal negative 50. Now I'm going to add those together, and my y's should cancel out if I've done it properly. And so I'm going to get 14x. That's going to equal negative 28. 22 minus 50. 50 minus 22 is 28, so therefore 22 minus 50 is negative 28. I'm going to divide by 14, divide by 14. X is going to equal negative 2. All right, if x is negative 2, then I'm going to plug it into one of the original equations, either this one, this one. I could use this red one, but I don't know why I would. It's a doubled version of the second one. So in this case, I think it's smarter. I'm just going to use the 2x plus 3y equals negative 25. So I'm going to have 2 times negative 2 plus 3y equals negative 25. Okay, and so I'm going to get negative 4 plus 3y equals negative 25. And I'll add 4 to each side. And that'll get me 3y, which equal negative 21. I'll divide by 3, and I'll get y equals negative 7. So the solution to this is at negative 2, negative 7. Sorry if it looks like I'm writing uphill. I'm laying on a bed and holding my computer up. It's going to shut down on me when it gets too hot, and so I'm holding it up so it can kind of cool itself. This is actually my second attempt at this video. I was half done, and it didn't work, and I almost cried. But anyway, so there's 3 different ways to solve systems. Remember, you're going to have to use all 3 ways and show you can do it. All right, now I have a system of linear inequalities. I'm going to pretend that they're equations to begin with, and I'm going to find information like x-intercept, y-intercept, etc. I think the y-intercept of this yellow one will be really easy to find. Y-intercept, it's in standard form, is going to be 0, 9. And so that's going to be right here. Okay, the x-intercept is going to be a fraction, but the slope's easier to work with, so I'll use the slope. And that'll be what? Negative 2 over 1. And so it's going to go down 2 over 1, just like this. And if you notice this, 1, 2, 3, 4, 5. Look, the line is going to cross in between 4 and 5. Remember I said there was a fraction involved? Yeah, it's actually the x-intercept is 4.5. All right, so I'm going to draw this one in here. And I'm going to go along there. And I'll put an arrowhead on there. There we go. And I'm going to go ahead and shade. Oh, remember though, to determine where I need to shade, I have to use a test point. I'm going to use the origin as long as my graph doesn't go through it. So I'm going to plug 0 in for x and 0 in for y and see if that's less than 9. Simplify the left-hand side. I get 0 is less than 9, which is true. So I will shade where the test point is. So I'm going to shade here. And then everything to the right. Excuse me, to the other right, to the left. Okay, oops, went over a little bit. I'll see if I can erase that. Okay, so that's the graph of that. And there we go, that's pretty good. Now I'll do the blue one. And it's in standard form. The y-intercept of that one is at 0, negative 4, so it'd be 1, 2, 3, 4. Oh, by the way, it's a broken line because it's not equal to, right? Okay, my slope looks like it's going to be a negative 1/3, right? Negative 1/3. Yeah, slope is negative 1/3. So I'm going to go down 1, 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. Okay, looks like I might want to do just a little bit more shading based on the fact that I'm going to come down here. And I think I might even extend my line a little bit so I can see my solution a little bit better. So let me put that and go something like that. Oops, am I off the points? I am a little bit. So let me move that over a smidgen. And there we go. Okay, so now I got to draw this other line in, and it'll be a broken line as well. And the broken line will go like this. And okay, so we go like that. Let me get an arrowhead on there. Okay. And now I got to do a test point and see where the um, see where I should be shading. So I'm going to plug 0, 0. I can use the origin again for my test point because the line does not go through the origin. I do 0 plus 3 times 0. Is that greater than negative 12? Well, the left-hand side simplifies to 0 again. And is that greater than negative 12? It sure is. So that means I'm going to simplify, or excuse me, I'm going to shade to above the line. Okay, so I got a true statement, and that means I'm going to shade where above the line where the origin lies. And so it's going to be like that. And notice my solution is the green area. See, for just the one line, I have to shade, and I'm going to have lots of blue on the other side of the first line I graphed. But in between the two lines, it's supposed to be all green. Now, it might not quite be because, it's kind of hard to shade precisely in here. I don't even know where I'm at. Ooh, I'm way over there. Okay. So the solution is this green triangular region. And of course, it would be solid green, but it's difficult to do it precisely. And there's my solution. Okay. Any point in that green shaded region is true for both inequalities. All right, last one. On this one, I've given you a line. First thing you want to do is figure out the equation of this line. Remember, we need a slope and we need a y-intercept. Well, geez, the slope is at 1, 2, 3. So, excuse me, my y-intercept is at 0, 3. Okay, my slope is down 1, right 3. So it's going to be negative 1/3. Okay, so my equation is y equals negative 1/3 x plus 3. What's the equation of a line parallel? Well, first of all, I need the parallel slope. Now, this is not m sub 11, that's the slope parallel. And the parallel slope would be exactly the same, right? Now, what's the y-intercept going to be? Well, I'm going to use y equals mx plus b. Okay, and so I'll put the, oh, I didn't give you enough information. I got to tell you what point I wanted to go through. I wanted to go through the point, say 6, 4. Okay, so my parallel line is going to go through 6, 4. 1, 2, 3, 4, 5, 6, 2, 3, 4. Okay, now I know you could just draw it on the graph, but I need an equation. I need to do it algebraically. So I know y is 4. I know m is negative 1/3. And I know that x is 6. I'm solving for b. That's a 6 there, by the way. Oh, that looks terrible. Let me rewrite that. 4 equals negative 1/3 times 6. There we go. That looks a little bit better. Okay, so I'm going to get 4 equals negative 2 plus b, and b is going to equal 6. So my new equation is y equals negative 1/3 x plus 6. That's the equation of the line parallel to it. Let's check it out. I'm going to go to the, let's see, 1, 2, 3, 4, 5, 6. There's the y-intercept. And the slope is down 1, 1, 2, 3, down 1, 1, 2, 3. That's good. It hit the point. Now watch what happens if I clone this line. Okay, boom, it hits those 3 points exactly. So I did that one right. Now I want the equation of the line perpendicular to it. Well, I'm going to need the slope. It's got to go through the 0.64 still. My original slope was negative 1/3, so my perpendicular slope is the negative reciprocal. So I flip it and change the sign. Okay, so now I put 4 equals 3 times 6 plus b. It's going to be 18, and plus b. B is going to equal negative 14, right? So my new equation is y equals 3x minus 14. So the y-intercept is going to be negative 14. This one's not going to fit on the graph so well, but I can guesstimate. 1, 2, 3, 4, something like that. And my slope is 3 over 1, so I'm going to go up 3 and over 1. Go 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, and there it's hitting the point that it was supposed to. And if I draw it in, even though I had to kind of guesstimate, look, it's going to look nice and perpendicular. Yeah, you see that? You get a nice 90-degree angles as they intersect, actually creating 4 90-degree angles, okay, when they cross each other. So there you go. That's your little ICANN video to help remind you of all the things you're going to need to know. You know, if I'm doing a review type video, it usually means some kind of assessment is coming soon. So anyway, Mr. Lawrence signing off. Have a good night, everybody.